insertion operation of double linked list with reference to this train example. So we shall continue with the same example. In order to visualize the double linked list structure, one of the easiest and real-time example is a train example, where we have different compartments and each compartment is a new node in which it has three segments. We call it as the first segment as a previous window, which will store the address of the previous compartment which is there attached to this. And if any compartment is attached to the next of it, we will represent it using the next window. So we will assume this previous and next to be windows, and we will assume that this compartment is having the capacity to carry only one passenger at a time, and that passenger name is data. So this is how the double linked list structure will go. And to indicate that which node is the first node among these compartments, we will use a head pointer which will store the address of the first compartment. And normally we can take any address. Here I am taking the addresses S1, S2, S3, which are the names of the compartments. So that the address of this total node is S1, first one. Address of total node is of second one is S2. Address of this total node, including all the three segments, this is S3. So let us go forward with this example. So this is the function to delete a node from the beginning. Now how to delete a node from beginning? So this is the first node which I have. The name of this compartment is S1, second node is S2. I want to delete the node of S1. When I delete first node, see, that means you are removing the connections between the engine and the second compartment, right? So if you directly remove the S1 compartment, the train will not move forward. Okay, when S1 is detached. So what we do is we first attach this engine to the second compartment and then we will remove the first compartment, so that the train will move without any disturbance. So let us see the functions. So let us see the C program here. So if there are no compartments at all, there is only one engine which is working and there is no any other compartment. So simply the address of the head, so it will point to 0 because there is no compartment at all after engine. At that time head will be equal to null. Otherwise, if there are any compartments followed after engine, that is head, then we have to check where is the first compartment and remove that. So before removing that, connect the head to the second compartment. So here we have to just think about head pointer node 1 and node 2 only. We don't bother about node 3. We have to modify the connections between head, first node and second node only. Right, for that we are writing the code. So first we will create one temporary variable here. So node star temp equal to head, and that will carry the temp address head. So first we have to create an address from head to S2. So here that's why we are writing head equal to head of next. What is head? Head is S1. What is S1 of next? S2. So we are moving head to S2. So S2 is copied to head. Now head is not S1, it is S2. Now it is moved to, it is carrying the address of the second compartment. And then S2 because it is attached to second compartment. So this is the second compartment and the first compartment will be removed with the help of this free temp. So temp is a variable which is actually storing S1. So when you are connecting the head to second compartment, you are losing the first compartment address. So that we are first storing in temp and then we are connecting head to S1. Now we are just removing free. The temp means we are removing S1. So that is how S1 is dropped. Okay, so temp equal to S1. So that is what it is dropped. Then function to delete a node from the end. So here if you want to delete a node from end, first of all you should start moving from the engine, then move to first compartment, then second compartment and so on until you find the last compartment. And how do you identify this last compartment? The last compartment will not carry any address. Next of that last compartment will be 0. Okay, which means there is no other compartment after that. So that is why in this window next is equal to 0. So if head equal to null, that means when do we say head equal to null? If there are no compartments at all after engine. So there is single engine. So we can't remove any node. So for that we will write list is empty. There is no compartment. Otherwise, first copy temp equal to head. Okay, so first we will take temp equal to head. So, and then we'll start moving. If temp of next, so first temp is equal to S1, that is head, and then it will check S2. What is temp of S2? Is it equal to null? No. If it is not equal to null, this temp will move to the next node. So we'll come out of this if loop. If it is equal to null, it means it is the last node and we will simply remove this. Otherwise, we have to move to the next compartment. So for that, if this is equal to null, we don't remove that first compartment. So temp will point to S1 and we don't remove this S1. So we will go to the next step. Temp of next not equal to null. So temp is S1. What is this temp of next is S2. So that is S2 and it is not equal to null. It means there is another compartment S2 after S1. So we will move temp to temp of next. So here we will get S2. So temp is moved to S2 now. Then now you have to check this one. So again check the while loop. While loop will be done. Is temp of next, temp is S2. Is S2 of next not equal to null? No, it is equal to null. So we will come out of this while loop. So we should not move further. So we got the last node. Now our next step is remove this one. So before removing, you have to remove these connections. So for that, you need to make this S2 as 0 and then remove this, which indicates that when you remove this, you should give information at S1 that there is no compartment attached here and this next should be 0. So for this, what we have to do, temp is at S2. From S2 we have to move to S1 now. So how do we move to this? We have to, where is S1 address in the temp S2? It is in this first window, in this first segment. So temp of previous is S1. So we will go to temp of previous, which is S1. So from here we are moving to this node. Again in this node we have to check the segment. We need third segment only. We don't bother about first two segments. So again in this temp of previous, so temp of previous is S1. After moving to S1, go to the particular segment. So particular segment is, again we will write a link structure. So temp of previous is total node. Under that, if you want to go to one of the segment, here you have to write either next, previous or data. So here it is next of S2. So we'll go to next 2 and here instead of S2 we are making it as a null. Immediately this link will break, which is pointing from the next equal to S2 to previous of S1. So this link will break and immediately it will become next of 0. Okay, so this S2 has become 0 now and head is pointing to this only. There is no change in the head and now we are making free temp. So that's why temp is made free, that is the address of S2 is removed from the temp. Now temp is equal to 0, it is not equal to S2, so that's why that compartment is deleted. Okay, so this is what we are left with these first two compartments. So this is about deletion of a node from the end. Okay, then function to delete a node from a random position. Okay, I don't want to delete a node from beginning or end, I want to delete at some random position. Now see here, so this is position 1, this is position 2. I have the compartments S1 and S2. So let my position equal to 2. I want to remove the second compartment. In this train, there are total 3 compartments S1, S2, S3 and I have to remove S2. That means after S1 I should get immediately S3. I should not get S2. Okay, so for that I need to traverse. I need to traverse up to that position, up to S2. Whenever we are traversing, we need some temporary variable which carries the address of the node, and whichever variable is carrying the address, we need to use a pointer. So node start temp equal to head, int I equal to 1, I less than position I plus plus. So here we will start with position 2. Is 1 less than 2? Yes. So it will come here. Is temp equal to null? Temp is actually starting from first address, first compartment, that is head. So head is S1. So temp is also S1. So it is not equal to null. So that means we have some compartments and we can move further to the particular position 2. So this particular if block will not be executed. Then we come here, temp equal to temp of next. So temp is S1, temp of next is S2. So S2 will be copied to S1 now. Now temp is S2 now. Temp is pointing to the second compartment. Now it is not at S1, it is now at S2. And then again go back to the loop. Now I plus plus, now it is 2, is 2 less than position 2, so it is false. So we cannot run the for loop. So within the for loop we have this if statement, we also have this temp equal to temp of next, so these two statements will not be executed. We'll come out of the for loop. So for loop is ending here, so here we'll come here. Now at this position, now what we have to do, whenever you want to delete this particular s2, if I delete s2 directly, I won't get the links from s1. If I want to attach s3, I need to take the help of s2 only. See, we cannot travel in a compartment from s1 to s3 directly. We have to move from s1 to s2, then s2 to s3 in a train, right? So if I delete these particular links, if I delete s2 directly, I will miss the connection between s1 and s2. So that's why we will connect s3 to s1, and then we will remove the links. So for that we are writing temp of next equal to is temp of next not equal to null? Yes, it is not equal to null. There is another compartment after this. Then we have to attach the next compartment of s2 to previous compartment of s1 of s2. So that's why we have to connect s3 and s1. So temp is at s2. So what is temp of next? We have to go to temp of next, that is s3. From s3, how do we connect s1 and s3? The previous window of s3 has to be connected to the next window of s1. So there should be a link from here to here. So we are moving from s2 to s3 using this line temp of next. Now we are at s3. In s3 I have to choose the first segment only. I don't want data in next. So that's why I am writing again of previous. So it will select only this first window. Okay. So after first window, so it will go to temp of previous, and temp of previous will be updated to is equal to temp of previous, so which is s1. So here temp of previous is s1, so s1 will be connected to s2 here. Okay, so previous is connected to s2 using this particular statement. Then after connecting this, now s3 is connected to s1. Similarly, s1 has to be connected to s3. Now for that, again we will check. We have to go to s1. From s1 I should get a link to s3. Now if temp is at s2, how to move to s1? I will take s2 of previous, which is temp of previous. Is temp of previous not equal to null? I am just checking whether there is any compartment before s2. Yes, there is a compartment which is not equal to null. So if this is not null, if there is some name of the compartment is there, it means there is a compartment before s2. So it is not null, it is s1. That means s1 is there before this. So first we will move to f1 using temp of previous. So here we are at position s1. In S1, which of these three segments do we require? We require only next. So third segment. So here that's why we are writing of next. In this position, what we should write? Instead of S2, I want S3. So S3 is under this next. So temp of next of S3. So assume that S1, S2, S3 are not written on the compartment. They are not written as names. They are actually written in the either previous node or the next node. That is either previous compartment or next compartment. So this is temp of next, temp of, that is s3. So that value is copied to this temp of previous of next. Okay, so now instead of s2 I will get s3 here, and then free temp. So this will delete this